Hi everyone, welcome to the session for problem solving through the ANSYS. Now this is the first problem. So definition of the problem is like this. It's a uniform bar as shown in the figure. So this is a uniform bar of diameter 25 mm fixed at one end and subject to the point force at the free end. So in this problem we need to determine the displacement, stress, strain and the reaction at the fixed support. For this we need to take the one dimensional bar element and we have to use the elimination method where we are dealing with the FEM approach. So but here we are solving with the software. So with that Young's modulus value is 2 into 10 to the power of 5 Newton per mm square. Now when I solve using FEM approach, so these are the values I am going to get. That is displacement at node number 1, that is at the fixed end it is 0, and the displacement at the free end where the point of application of force, there I will get the displacement as 63.66 into 10 to the power of minus 3. Similarly, when I calculate the strain in this member, it is 2.55 into 10 to the power of minus 4. Then the stress is 50.93 Newton per mm square. Then finally, reaction at the fixed end is minus 24.99. These are the values when you calculate using FEM approach. Now the same problem we will solve using the software. Here in this we are using the ANSYS software. So let us open that ANSYS software. Now to begin with ANSYS software, first we need to select the preference. In the preference we need to say whether it's a structural or thermal analysis. As we are doing a structural analysis, we need to select the structural. Then you say OK. Then you go to the preprocessor. In the preprocessor I need to select the element type. So in the element type I need to select the type of the element which is required for the analysis. So it is a one dimensional analysis we are doing, therefore I need to select the one dimensional element. So where link is the one dimensional element, then you say OK, then close this menu, minimize this, then come to the real constant. So I need to add the real constant. A real constant is nothing but it's a area of the whatever the bar I have considered. So I have given the diameter. When you convert that in terms of area, that is pi by 4 into d square. So that value comes around 490.87. So I'll enter that cross sectional area. It is 490.87. Then you say OK and close this. Now after giving the real constant, you come to the metal property. I need to mention the metal property for the given problem. Where I have mentioned Young's modulus value is 2 into 10 to the power of 5 Newton per mm square. Therefore I'll enter that value. For that you need to go to the metal models. Under metal models you have to select structural. Under structural, linear. Under linear I need to select elastic and I need to give the isotropic value which is 2 e raised to 5. And as it is a one dimensional problem, I need to give the Poisson's ratio as 0. Then you say OK, then go to the metal and say exit. Now after giving the metal property, you come to the modeling. In the modeling, you need to create the nodes. So for that you go to the create menu. Under that click on the nodes. Then you select inactive coordinate system. So first node I need to create at the origin. Therefore the values for first node is 0 0 0. I'll enter all xyz coordinates as 0. Then you say apply. Then change the node number 2 and give the value as 250 in the x direction. Y and z are 0. Then you say OK because this is the final node. So I'll click OK. Once you click OK, you come to the under same create. I need to create the elements. Go to the elements, auto numbered through nodes. Select the node number 1 and 2 and you say OK. So this is what my element I have created. I have 2 nodes and 1 element. Now after creating the element I need to go to the load section. Under loads I need to apply the loads, therefore define loads, then apply structural displacement. Now I need to give the complete constraint to the node number 1, therefore I will select on nodes, select node number 1, OK. Then you say alt DOF, that is all degrees of freedom I need to select because the left hand side is completely constrained. So alt DOF, OK. Now after constraining the left hand side, now I need to apply the force on the right hand side, that is at node number 2. For that I need to go to the force. Once again I need to apply the force on the nodes. So select on nodes, select node number 2, OK. Then I need to give the force in x direction, therefore I'll select this fx. Then I'll give the value which is 25 kilonewton. So it is 25 e raised to 3. Then you say OK. So this is what the force of 25 kilonewton applied at node number 2. Now once this is done, now the problem is ready to solve. So for that I'll go to the solution section. Under solution I need to say solve current ls and you say OK. Now once the solution is done at the back end, it will give the message solution is done. After that you close this. Now I need to go to the general processor. There I need to check for the results. First let me check the displacement. So for that I'll go to the least result. Under least result I'll go to the nodal solution and DOF solution. Now applied force is in x direction, therefore I'll get the displacement in x direction. Therefore you select x component and you say OK. So the displacement at node number 1 is 0 and the displacement at node number 2 is 0.63662 into 10 to the power of minus 1. Nothing but it is 63.66 into 10 to the power of minus 3. So that is what the value I am going to get as a displacement. Now similarly I need to check the values of stress and strain. For that I need to create the element table. You just go to the element table, define table, add, then take this down to the by sequence number, then select this LS, give the number 1, apply. Similarly pull this down, go to the by sequence number, select LEPL, give the number 2, say OK, then you close this. That means I have called out the two results. LS is nothing but stress and LEPL is nothing but the strain. Close this. Then once again you can come back to the list results. In that you can go to the element table data, select this LS and LEPL and you say OK. Then it will give the values of stress and strain. Say I have only one element here, therefore in one element I have a LS means stress I told. So stress is 50.93 and LEPL is nothing but 0.2546 into 10 to the power of minus 3. Nothing but it is 2.54 into 10 to the power of minus 4. So that is what the values of stress and strain I am getting. Now once the values of stress and strain seen, next finally I need to check the reaction solution. I'll go to the reaction solution. Now applied force is in x direction, therefore I'll get the reaction in x direction opposite to that at the fixed end. Therefore I'll select this Fx and I'll say OK. So this is a reaction of minus 25,000 Newton because applied force is plus 25,000. Therefore the reaction is minus 25. Okay, this is how we need to solve the problem using ANSYS. Now we'll compare the values with whatever the mechanics of metal you are done. Now this is the values what we are done with the FEM approach. Now these are the values you obtained through ANSYS. Now almost the values are matching here. So this is how we can solve the problem using ANSYS. Thank you.